Hi, this is going to be lesson 4.2. We're going to be talking about rates of change. Okay, we're talking about constant rates of change. Our standards is I can define and identify a proportional relationship. I can write an equation for a proportional relationship. The standard is RP2, recognize and represent proportional relationships between quantities. So I'm going to minimize myself and we will begin. Okay. What is a rate of change? Recall that a rate is a ratio in which the two terms are in different units. For example, miles per hour. So a rate of change, this is from previous lesson 4.1. If you need review on that, you can go back to 4.1 as well and check that out. A rate of change is a rate that describes how one quantity changes in relation to another quantity. Rates of change can be constant, that means they're the same, or they can be variable. Variable means changing. Have you ever heard of a variable in an equation? It's a letter, right? It means the number can change. Recall that a proportion is a statement that two rates are equivalent. And we have over here on the right what we've been working with from the last lesson. Let's grab my spotlight here. Right here, we notice that we have miles and miles on top and hours on the bottom. And then we can set up a proportion and solve for any of the missing pieces. So 60 miles, the person will go in 1 hour. 120 miles, they will go in 2 hours. These statements are equivalent. And the proportional relationship between two quantities is one in which the rate of change is constant, or the ratio of one quantity to the other is constant. So this relationship right here is a proportional relationship. So hopefully that should be reviewed for you. Let's move on. Discovering a proportional relationship. A giant tortoise moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches. So let's put our rate up. So we're going to put inches on top and seconds on the bottom. So every 3 seconds, he goes 10.5 inches. Using this rate, let's complete a table by setting up proportions. Okay, we know the one in the table there. So we have the independent variable x, that is time. Time is independent because it doesn't depend on anything else. It just keeps happening and happening. And then below that, we have the distance in inches. That is the dependent variable because it depends on how much time has gone by. So we know that after 3 seconds, this turtle goes 10.5 inches. So we have to figure out how many inches it goes after 1 second, 2 seconds, 4 seconds, and 5 seconds. We're going to do that using our rate up here. So 10.5 inches over 3 seconds equals y over 1 second. So now we're going to solve for y. We're going to cross multiply and divide. So cross multiply 10.5 times 1. And then what are we dividing by? Right, we're dividing by 3 seconds. So if we did that with our calculator, we would get y equals 3.5. What does that stand for? The turtle will go 3.5 inches in 1 second. So let's put that in our table and let's continue. Now we set up a new rate for the 2. 10.5 inches over 3 seconds. And notice how we're using the same rate every time. All we're changing is the amount of time. So 2 seconds is going to go on the bottom here, right here. And we're doing the same thing. We're going to cross multiply and this time divide again by 3. So we're going to type times 10.5 times 2. So on your calculator, you do 10.5 times 2 equals, and then divided by 3. So y equals 7 inches. So the 7 is going to go in the 2 column. And now we do the same for the 4 seconds. So we have our same rate, 10.5 over 3. This time we have, notice, a 4 right here on the bottom. So we cross multiply and then we divide by 3. That'll give us y equals 14 inches. Put that in. And then our final one, go ahead and pause the video and try that. See if you get the right answer, and then check your answer. Okay, hopefully you pause the video. So we have 10.5 over 3 equals y over 5 seconds this time. Cross multiply 10.5 times 5 equals, divide by 3, we get 17.5. So now we have just made a table that goes with our rate in our word problem. So we've got some points here. We have an x point and a y point, an x point and a y point, an x point and a y point. And if you think about a coordinate graph, you could graph these points correctly on a graph. Okay, here's our table that we just had on the previous slide. We figured out the answers here. So we can say that the rate is 3.5, or we could say 7 inches over 2 seconds, which is also 3.5. If you took a calculator and divided 7 divided by 2, you would get 3.5. If you took 10.5 and divided by 3, you would get 3.5. If you divided 14 by 4, you would get 3.5. And can you guess what the last one will be? 17.5 divided by 5 will equal exactly 3.5. The rate is constant. That turtle doesn't go slower. It doesn't go faster. It goes the same speed all the time. He has a constant speed of 3.5 inches per second. So there's the rate. It's the same every time, right? So the ratio of distance to time is constant. This is a proportional relationship. A proportional relationship's definition, remember from the first slide here, is that the rate is constant. The ratio of distance to time is constant. Okay. Let's look at another example. Callie earns money by dog sitting. Based on the table, is the relationship between what Callie earns and the number of days a proportional relationship? So here's the table. So here's the number of days, 1 day, 2 days, 3 days, 4 days, 5 days. That's your X, your independent variable. The amount earned, Y, is your dependent variable. So if she babysits, dog sits for 1 day, she gets $16. And if she babysits for 2 days, she gets $32. 3 days, she gets $48, etc. Let's put up our rate. So based on the rate, we get $16 in 1 day. So we know this is the rate because it's the unit rate, because 1 is on the bottom. So let's see what that equals out. Let's see if it's proportional. So 16 over 1 equals 16. Let's try 32 over 2. What does 32 divided by 2 equal? You can use your calculator if you want, or you can know in your head it's $16, right? Let's try 48 over 3. Does that also equal 16? It does. How about 64 over 4? Does that also equal 16? Yes. And then finally, 80 divided by 5 equals 16. So the rate is constant. The rate is the same for every set of day and amount earned. So we have a proportional relationship because the rate is constant. So you have to do these little tests to see. Okay, you got to do some problems here for your turn. Number 1, pause the video, do the questions, and then come back. Okay, welcome back. The constant of proportionality. Okay, the constant of proportionality represents the constant rate of change or constant ratio between x and y. This constant is represented by the letter K. In order to have a constant of proportionality, K, the relationship must be a proportional relationship. So on our previous slide, what we were doing is we were taking the table and we were putting y on top and x on the bottom, and we were dividing those two numbers, whatever they were in the table, and getting some kind of a constant number. So the formula for K is exactly what we just did in the previous slides. Divide the Y number by the X number. That's your constant of proportionality. And you can also use your algebra, which we'll be learning more about as the year goes on, to rearrange this formula into this equation. Now my black bar is at the bottom. But if you rearrange that formula algebraically, that K equals Y over X, you can rearrange it in such a way to get Y equals K times X. Y equals K times X. That's your standard slope intercept equation that you're going to be working with a lot next year and somewhat this year. So know that those two situations exist. They're based off of the same formula. Okay, remember that K represents a constant rate of change or a constant ratio between two different units called X and Y that have a proportional relationship. So 2 pounds of cashews cost $10, 3 pounds cost $15, and 8 pounds cost $40. Write an equation for the relationship. Well, the numbers in my problem make it very easy for me to already make a table. So here it is. So X is my pounds of cashews. They don't depend on anything, right? But the cost for these pounds of cashews does depend on how many pounds I buy. So I just put the numbers from the problem into the table. So 2 is written in words. So 2 is here, and it cost me $10 for 2 pounds. It cost me $15 for 3 pounds and $40 for 8 pounds. That's right directly from the word problem. Now I have to figure out how to write an equation for this. So step 1, we're going to find K, the constant of proportionality. How do we do that? Well, what was the formula? K equals Y divided by X. We have 3 Y's here and we have 3 X's. So we could do 10 divided by 2, 15 divided by 3, and 40 divided by 8, correct? So let's do that. Our rate is 10 over 2. That's K. That equals $5. 10 divided by 2 is 5. Then we have to do 15 over 3. 15 divided by 3 equals $5. Then we have to do 40 divided by 8. That equals $5. Do we have a proportional relationship? We do, because it's $5 for every set of points when we do Y over X. So we do have a constant of proportionality. What is it? It should be $5. So step 2, write the equation for the relationship by replacing K with the constant of proportionality that you calculated in Y divided by X. So there is the manipulation algebraically of our formula up here. This is the way we can write it now. Y equals KX. We're just going to plug this 5 in for K, and we'll have our equation. So let's see if that pops up for us. Yep, 5 is going to go for K. So there's our equation. Y equals 5X. You leave the Y and you leave the X in the equation. So how much does it cost for each pound of cashews you buy? How do we figure that out? Well, we can use our equation. Y equals 5X. Oh, I'm sorry. I'm going to go back. Well, what it was is, I don't know if I can go back. Can I go back? I think I can go back. Back up there. Da, 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 da. How much does it cost for each pound of cashews? It should cost, I'll go back to that question again. There. It costs $5. We got that right from the equation. Just wanted to make sure you knew where that was. Okay, next. The constant of proportionality. For a school field trip, there must be 1 adult to accompany 12 students, 3 adults to accompany 36 students, and 5 adults to accompany 60 students. Write an equation for the relationship. Well, we've got our numbers in our word problem. Let's make a table. So the number of students, if we have 12 students, we need 1 adult. Notice how the students are the independent variable. They don't depend on anyone else, but the number of adults depends on how many students there are. And then I plugged in 36 and 3 and 60 and 5. Now, step 1 is to find the constant of proportionality using our equation y divided by x. Do the first one. Y is 1. Be careful on this one. The 1 is on the top, right? 12 is on the bottom. That's how it should be. It just, even though that's smaller number, that's okay. Sometimes your rate is a fraction. So the next one is 3 over 36. Y divided by x. If we reduce that down, we get 1/12. And then 5 over 60, if we reduce that down, we get 1/12 as well. So that is K. K is 1/12. So for every 12 students, we need 1 adult. Write an equation for the relationship by replacing K with the constant of proportionality. So y equals kx. Well, we're going to plug in 1/12, our K. So we're going to put it in right there instead of K. There it is, y equals 1/12x. That is the equation for this relationship. What is the ratio of adults to children? The ratio is 1 adult per every 12 kids. Okay, staying with me so far? Good. How many adults need to come if 84 students go on the field trip? How do you figure that out? Well, y is equal to 1/2 and 12, or 1/12. And then you're going to put in 84 for this. Let me draw it. You're going to put in 84 for this x here, because x is the number of students. So then what I'm really doing is multiplying 1/12 times 84. And if you want to use your calculator to change 1/12 into a decimal, it would be 1 divided by 12 on your calculator, or you could use a fraction and you could do 1/12 times 84 over 1. And if you were to divide 84, then 1 times 84 is 84, and 12 times 1 is 12. So you have to do 84 divided by 12. So that's another way that you could do it if you want to. And if you did 84 divided by 12, you would get 7. So here's the answer. Y will equal 7 adults. So that's where this 7 comes from. You multiply 1/12 times 84. So you'll need 7 adults on this field trip. So that's why an equation is a good deal, because once you can establish an equation, you can plug in any number of students and figure out exactly how many adults you need to go along on the field trip pretty easily. So that's why equations are useful. Okay, you get to try a few more. Pause the video, try the questions, and then come back. Okay, welcome back. Hopefully you paused the video and did your questions. Let's continue. Let's focus on some higher order thinking. A submarine dives 300 feet every 2 minutes and 6,750 feet every 45 minutes. Find the constant rate at which the submarine dives. That's going to be your K. Give your answer in feet per minute and feet per hour. Then write an equation for the relationship. Got lots to do on this problem, so let's take a look at it step by step. So we're going to let x equal minutes, because time is always x. Time is independent of anything else. It's the independent variable, and x is always the independent variable. And then we're going to let y equal the other unit we have in the problem, which happens to be feet, the feet the submarine dove. Okay, step 1, find k, the constant of, constant of proportionality, not or. Hopefully the other one, I didn't check the other ones. So y equals k over x. Can't see it because it's hidden behind there. K's rate then is 300 divided by 2. I'm taking it right from the problem. If you wanted to make a table, you could, and then do it that way. This time I'm just showing you we don't have to make the table always. So 300 divided by 2 is equal to 150. Now we're going to take 6,750 divided by 45 minutes. That's going to give us also 150. So 150 seems to be the rate, the K. The sub dives 150 feet per minute, because we've been talking about minutes. So now we have to do the second part. Give your answer in feet per hour as well. So the sub dives 150 feet per minute times 60 minutes, because there's 60 minutes in 1 hour, right? So they'll dive 9,000 feet per hour. See how I did that? 150 feet per minute, and then there's 60 minutes in an hour, so that's 9,000 feet per hour. So step 2, we're going to write the equation for the relationship. We're going to replace K, 150, in our equation. So y equals kx, replace k with 150. There's your equation, y equals 150x. Okay, you get to try one of these your turn problems, and we'll see you back. Okay, your homework is on Google Classroom, and I hope that you have a good day. Bye.